Everyone. I want to talk to you a little bit today about Cynic, my Rust GraphQL client library that I've kind of been obsessing over for the past year. Far too long, really, but it's fun, so never mind. Well, first, wrong window. First, a little bit of background. So I work for Red Badger, like everyone else that's presenting today. And one of our clients is Nando's. And we've been working with them for a while to help them build an app and some backend services to allow customers to order some Nando's. Quite early on in this project, we needed a source for menu data. Now, Nando's menu is quite complicated. There's a whole bunch of different bits of data that they have about the menu. And we knew across the course of the project that there would be a whole bunch of different consumers of this menu data. Like there's probably going to be a few different clients that people order food from. There's going to be some backend services that need menu data. And we've not built these yet, so we don't really know what their needs are. So we decided that we'd build a GraphQL API for this menu data because it allows us to just like define all of the data that's available and the shape it's available in, and then clients can just decide what data that is or which bits of the data they want to pick. One of our other requirements was that we wanted Nando's employees to be able to edit the menu. So we decided we wanted some sort of content management system for them to do that. So we decided on an open source CMS for this that would let us sort of define the shape of our data, and it would give us a GraphQL API and also a nice editing interface that the employees could use to edit that data. But unfortunately, quite quickly into designing the shape of the data with this CMS, we realized that if we designed the shape of the data for a nice editing experience, the GraphQL API that the CMS gave us would be rubbish. And the other way around as well. If we designed it for the GraphQL API, the editing experience would just be terrible. So we decided that we'd design the CMS schema for the editing interface primarily, and then we'd build a wrapper API around the CMS API that would transform that into the shape that we wanted to expose to our consumers. So we decided to write this in Rust because we kind of liked Rust and we'd had some success with it so far. And we went looking for GraphQL Client libraries that are in Rust so that we could talk to the GraphQL API, the CMS exposed, and put out a different GraphQL API in the shape that we wanted. So the one we found was called GraphQL Client. I believe it was the only GraphQL client library in Rust at the time. There's maybe a few more now. And it's got quite a nice, simple API that looks a little bit like this that you can see in the screen. You basically just define a struct. You derive GraphQL query on that struct, and then you pass it two parameters, the path to your GraphQL schema that defines the shape of the API, and the path to your GraphQL query that defines like the data you want to get from that API. So it's really nice and simple to use. Oh yeah, and also the important bit is that this derive goes off and generates like all of the different structs that you'll need to fetch the data from this API. So even though you see one struct on the screen here, this is actually going to go off and generate like 30, 40 different structs with all of the data in it that you need. So once we had that going, we decided we needed to get the query that we were going to use to talk to the CMS. Now, this is a bit of a snapshot of what it looks like. It's really small and you can't read most of it. And I've also had to omit a ton of it because it was even smaller when I put the full thing in there. It's about 160 lines long in total. It's quite complex and there's a lot of metadata here. But the details are not really that important. The main point is that it's a massive query and it's quite complicated. And I think because of this, we ran into like some issues with the existing GraphQL client that we maybe wouldn't have ran into if we'd just had some simpler queries that we were running. So some of the first issues we ran into were fairly minor. The first one is that you can't really see the code you're working with. Most people who've worked with code generation based on macros have probably encountered this. You want to go to definition on a struct that you're working with. You can't do that. You can't see what the fields are named. Sometimes autocomplete doesn't work. It's just not as nice as it would be if the code was written out. There's ways to work around that, but it was a bit annoying. And the second one was that the generated names were just awful. It names everything. It names the types that it generates based on the position it appears in the GraphQL query. So when we've got things that are nested about 7 levels deep, then there are seven type names in the name that it generates. There's an example on the slide, and as you can see, it's not fun trying to type that out on a regular basis, especially when autocomplete is not working. But these were fairly minor, so we just ignored them and carried on. But then we ran into some not so minor issues. One of them is that because it generates all these types for you, there's no way to change its output in any way. So if you want to put a slightly different derive on some of the structs that it outputs than others, you can't do that. You just have to not put any derives on it and then write all the code out manually yourself afterwards, which is not great. And the final one, which was nearly a deal breaker but wasn't quite, is that it doesn't share the types that it generates. So this query that you can see on the screen is for a menu item. And on that menu item has addable ingredients, so you can like add some cheese, or removable ingredients, like if you don't like mayonnaise, you can take that off. Now, both of those addable and removables are examples of the ingredient type, and they both have names. So you could probably share a type for those, but GraphQL Client doesn't do that, which means if you want to write functions that work across ingredients, you have to implement it for every time ingredients appear in the query. Another case where this bit us was with a money type. Money appears at quite a few different places in the menu, and it's quite often that you want to write generic functions that work across money, and there was no way for us to do that, and it was very annoying. We also at one point nearly had to duplicate the entire query with most of the structure remaining the same, but some minor differences. And that basically meant we were going to have another 30 structs to work with, and we're going to have to implement the entire API twice just to do that, that wouldn't have been fun. But thankfully, we figured out a way to work around it without doing that, and it wasn't a disaster, and we carried on with the project. But I kind of obsessed over this for a good few weeks because I really quite like GraphQL. But with all of these problems, I couldn't see a way that I could justify using it all of the time. They weren't necessarily major, but they were downsides, and there were probably reasons why we would not pick GraphQL over some of the alternatives. And I wondered if there was a way that we could change GraphQL Client itself to solve some of these problems. But I couldn't think of a good way to do that, because it's kind of fundamental to the way that it works, is that it wants to take a query first approach where you specify everything in your GraphQL query. But GraphQL queries just don't have the same features that the Rust language does. So you just can't express everything you can in Rust in a GraphQL query. And you wouldn't want to usually, but in this case, it kind of limits you. So I thought, fine, I'll write my own. And a famous last words is, how hard could it be? The answer is very hard, because I'm here probably about 14 months later and I've still not finished. But yeah, I thought it was going to be easy. So now that I've decided to do this, needed to set myself some goals. So like the things I wanted to achieve with this library. The first one, and the most important one, is that users should own their types. Kind of thought that the main problem with GraphQL Client was that people did not own their types. So I wanted users to be able to specify their own types, and then Cynic would kind of just figure out what to do from there. Secondly, I wanted it to be type safe. Like GraphQL has a schema, and that schema kind of is like a type system. Rust has a type system, and I want those two to link up so that we can catch mistakes in CI or even on your machine at compile time, and not like fail a query when a customer goes to make an order, which would just not be fun. I wanted it to be idiomatic Rust so that people who normally use Rust kind of just understand what's going on with the code just from looking at it. Ideally, not interacting with generated code too much, because I found that painful in GraphQL Client. And finally, I wanted it to be as easy as normal GraphQL. So this is one of the things that GraphQL Client really kind of got right, is that you can use all of the normal GraphQL tooling to build up your queries and then just paste that into a file, and it works with GraphQL Client. So it's nice and easy to get going with it. And I wanted to replicate that with my library. So now I'm going to go through like some of the process or the evolution of the API that I built. And in order to do that, I'm not going to use the menu API query because it's just too massive, and it would never, well, we'd be here for about a day if I was trying to do that. So I'm going to pretend that we have a simple blog. Now the schema is on the left-hand side. It's got a post type with a required title and a required content that are both, a title and a content that are both required strings. And then it's got the root query type that just has a list of posts that's required. Both the list and the thing inside the list is required. And then the query just asks for the posts, and it gets the title and the content from each post. So the first take of my API was kind of just figuring out how can we express GraphQL queries in Rust without too many fancy features. So we go and we define our post struct, which has just a title and a content that are both strings. So this is just doing the first thing on my list where I want users to own their types. Then we need a new function for that post, which just takes the title and the content as strings and puts them onto the post struct. And then this is the important part, which is the bit that's building up the queries. So there's a field function that you pass. The first argument is post, that says we want the post field. And then says that field is going to be a list with the function on the line below that. Then we've got this map to thing, which says that every entry of the list is going to get 2 fields, and they're going to put it into the post new function. And then the 2 fields it's going to get are the title field and the content field, and both of those are strings. So going back to that checklist from earlier, users own their types, so that's great, but it's not really type safe in any way. Like, we're manually specifying the names of fields and the types of fields. So if we get this wrong, we're not going to know until we run the query. So not good on that. It's definitely not idiomatic Rust. I stole some of these ideas from Elm, where this would maybe be a little bit more idiomatic, but it's definitely not good for Rust. But there's no generated code, so that's kind of good. So then, for my next take on the API, I kind of wanted to tick off that type safety box. So this time round, the primary difference here is that we've got this schema module. And inside that, we're going to call this use schema macro. Now, what that's going to do is that's going to read the schema.graphql, and it's going to generate a whole bunch of types and primarily functions, but a few types as well, that represent the shape of the schema in Rust. Then we've got the post struct and the new function from that are the same as the last slide. And then we've got this for building the query this time. So instead of manually specifying the names of fields and the types of fields, we're just using some functions that are on structs that were inside that schema module that we generated. But otherwise, this is basically the same code as the last slide. So this time, again, users own their types. It is now type safe, but we've kind of regressed on that generated code angle in that the whole query building process is calling generated functions, and I really didn't want to do that if I could avoid it. So this was a no-go. But I wondered if I could maybe tick off two of these with one stone. I don't know. By thinking about like other places in the Rust ecosystem where we have this problem. So Serdi, the serialization deserialization library, kind of has this as well. It's got this API for building serializers and deserializers, but you don't usually work with the lower level API. You often just stick a derive on your structs and use them to define your serializers and deserializers. So I wondered if I could do that, but for GraphQL queries. And this is kind of what that ended up looking like. So again, we've got this schema module, which does exactly the same thing as it did last time. And then this time we've got the same post struct as we had last time, but we're putting a query fragment derive on that struct. Now, that query fragment is going to look at the shape of the struct that it's on and verify that it's the same shape as the schema that we've given it, and then generate the code that we wrote by hand last time round. And then similarly, we've got like the top level query struct here, which we didn't need last time because we were just using some functions to do it. But this just, again, has a derived query fragment on it. This time we've had to tell it that the GraphQL type is called query because it doesn't quite match with the name of the struct. And this is going to generate like the outer part of the code that we've had in the previous two slides. And this time to build our query, we just have to call a single function called build. And in this case, we're passing in like an empty tuple, or void or whatever it's called, just to tell it that we don't have any arguments. So this has ticked off most of my checkboxes, and I was quite happy with the way this worked, but it still wasn't really as easy as normal GraphQL. If you have to go off and like write 160 lines worth of or transcribe a 160 line GraphQL statement into structs, you're going to be there for a long time, like staring at the schema and then like going back to your code and typing a bit. You're probably going to make a bunch of mistakes. It's just generally not going to be fun. So I wondered how we could solve this last bit. Struggled with this for a bit because I kind of liked the API and I didn't want to change it, but I wasn't sure exactly how to solve it. But again, I thought to like other places where we have these problems. So whenever you're working with a new REST API, you probably need some types to represent the responses and requests of that REST API. And one way to generate those is to take like the JSON that REST API gives you and paste it into an online tool, and then it will give you some generated structs that you can copy and paste into your project, and then you can just use them. So I wondered if I could maybe do that, but for GraphQL queries. So the first version of this looked a bit like this. It's classic programmer design. It was written entirely in Rust using the Seed web framework, compiled down to WASM. It was quite a fun experience. You basically just paste the schema in the left-hand box, paste the query in the middle box, and then it gives you some Rust code that you can copy and paste into your project on the right-hand box. Now, this is mostly intended as like a bootstrapping tool. You do this once at the start of your project to get the bulk of it built, and then you probably never look at this again, and then you just edit the structs as appropriate. But I still kind of wasn't happy with this because it's still not that nice. It doesn't look nice. It doesn't give you autocomplete. There's no way to you can't write your query in this. You would use the existing GraphQL tooling and copy and paste it into here. So I wondered if I could do one step better. And this is what I ended up with in the end. Anyone who's done GraphQL before might recognize this. This is basically Graphql, the GraphQL introspection tool, I guess. And it turns out it's quite easy to hack extra features into this thing, which is quite nice. So this is what I've got. So basically, there's a thing over the left-hand side. This is, in fact, let's pause that. So this is me building some queries to the Nando's menu API. So over at the left-hand side, you can tick a few boxes and it will build this query in the text box in the middle. You can also type GraphQL into the text box if you particularly want. You can hit the play button at the top and it'll go and query the menu API, and you can see the shape of the data that comes back. And every change you make is going to update the generated Rust down at the bottom that you can then, again, copy and paste into your project just to get you going really easily. And at this point, I was kind of happy with the project. But it took me a good few months to get to this point. And obviously the Nando's project doesn't stand still while I go off and mess around with GraphQL for 6 months. So by this point, the project at Nando's has grown, extra teams have been added, things have been shifted around, and the menu API is no longer my team's job. So sadly, I never really got to see how this library would play out as a replacement for GraphQL Client in the menu API. But we did find some other uses across various services we built. So often our services need to get restaurant data, so we can use Cynic to query the restaurants API, which is also GraphQL. Any clients of the menu API itself can also use Cynic for querying the menus. We've got a capacity management API that's GraphQL, and whenever any of our services need to query that, we can use Cynic. We've also used it for some auxiliary fun stats tools. So an example that's open source that I put a link to on the slide there is called get lead time. Sort of generates the lead, or calculates the lead time of commits from the point that they're made to the point that they get deployed onto our cluster, which is quite nice. So if you want to have a look at a project that actually uses Cynic, go and have a look at that. And it's really nice having this library because it means we manage to enforce type safety across service boundaries without compromising on types and having to use code generated types that just aren't in the shape that we want. And we also get nice compile time checks on these. So all of our code sits in a mono repo, and we've got a dependency system set up in the mono repo. So whenever one of the schemas of the API changes, that triggers a build of all of the clients that use that schema, and Cynic will let us know if some sort of breaking change has happened and the structs that we've defined are no longer in the right shape. It's really quite nice. And that's the end of that talk. So if anyone's interested in this, there's the link to the project. Go and have a look, maybe build something with it. If you want a job, there are some links to both the Red Badger and Nando's who are also hiring, both fun places to work. And yeah.